Yes.
Okay. Satya said my name is also like very long, Naga Vishnu Kandirubhavati, but maybe you can say and also write Naga. It is sufficient.
It's too late.
Okay, and I will be talking about the sensor fusion for vehicular networks. This was my master thesis, and this is not the area that I'm working now as a PhD student. But then the sensor fusion is a topic that can be taught for a master level course and also a first year graduate student, PhD students. So I would like to say, give you a motivation of what is the need for sensor fusion and what are the problems that it will handle. Did you ever associate with this kind of situation where you are stuck in traffic for very long hours? This is a common problem in countries like India, China, or in US where there are a lot of traffic. Maybe it is not the same here. We can see that hours of commuting is done because of this stuck in traffic, and also because the traffic goes very slowly, there is unnecessary fuel consumption and carbon dioxide emissions also. And it is, you can also, the picture is complicated. We can also see that because of this chaotic traffic situations, there are a lot of traffic accidents. Just to give you some, so we will see what are these problems and how can we solve them. One thing is like the government can involve in these problems and it can build new infrastructure, for example, to reduce the traffic congestion or maybe to reduce the traffic fatalities. But as engineers, we would like to pose a question: can we help in some situations like this? Can we reduce the problems in somehow? So this is the aim of my talk, of what we engineers can do from a signals and system perspective, and the outcome will be like I would like you to. I hope that you will be able to explain what advanced driver assistance systems are, and what sensor fusion is, and how sensor fusion helps in this advanced driver assistance systems. And also, I will try to explain what a cooperative adaptive cruise control is, and how will it help to alleviate these problems of traffic congestion and reducing fuel consumption. So let's get started. I would like to give you some numbers. I said that there are a lot of traffic fatalities going on. According to a 2004 World Health Organization report, it was reported that around 1.3 million people die every year due to traffic fatalities all over the world, and nearly millions of people are injured. And if we don't take action now, it was estimated that by 2020, 1.9 million fatalities may occur every year. So this is a very serious problem. And as engineers, we would like to, before solving a problem, we would like to see what is the root cause of the problem. And if we try to analyze why there are accidents happening, nearly 86% of the accidents are happening due to one of these reasons. It can be because of pedestrians, road conditions, driver, vehicle conditions, or due to some other reasons. I would like you to think what is the major share, what is the main reason for these accidents, and just let me know if you can make any guesses.
Vehicle condition.
Any other opinion?
There is no driver. Oh yeah, driver.
Pedestrians, road conditions, driver, vehicle conditions, and maybe some other reasons. And we can see that 86% of the main chunk is because of one of these. I would like you to think or guess what can be the reason for these accidents. One answer is vehicle conditions.
Yeah, driver. Driving too close, neglecting road conditions.
Yeah. Any other guesses?
I already said driver.
And what do you think?
Slippery road.
Maybe we are saying road conditions. Maybe.
Yeah, weather conditions.
And
Truck driver.
yeah, I think most of you have guessed rightly, and as Tom was saying, 86% are because of the driver, and you can't see this white one. It is very strange that PowerPoint picked up this color. 6% are due to the pedestrians, and road conditions, as you said, is like 5%. And as Tom was saying, maybe this was because the driver was going in a wrong lane, or he was violating all the conditions. These are some of the reasons why these accidents are happening. So just to sum up what I have been saying till now, traffic fatalities are causing millions of deaths every year, and 86% of the cases are due to the driver. And also there are traffic congestion, as I have pointed out in the beginning. This is causing more travel time and extra fuel consumption. Just to give you some numbers, in 2009, urban America, there was a study in US, and it seems in urban America, 4.8 million hours of extra time is spent due to just travel because of this congestion of roads, and it costs a congestion cost of around $115 billion. So this problem is very serious, and maybe based on these things, maybe you have guessed that driver assistance systems can be a possible solution. Maybe we can assist the driver in some way, helping him to take decisions properly. This is a good research area now. A lot of people are working on this, and Volvo has been very active. Volvo in Sweden. For example, if I want to give you an example, this is a forward collision warning system. If a vehicle is about to hit a other vehicle, then the software in the vehicle will warn the driver that you are about to hit, and then it will automatically brake if you are not taking any action. And for example, in the lane violation, which was one of the main reasons, if the vehicle is about to deviate the lane, then the driver gets an alert that he has to get back into the lane. So this is one type of driver assistance system that is in place now. I would like to give you a short video that was taken very recently. It is a Volvo emergency braking system. It is done very recently, like a month ago, or it was in January 16th, so it's like less than a month. Did you watch this video? This is a collision warning system. I would like, we can first go through this. This is a dummy vehicle in red. Since this was in development phase, first they have done it with this dummy vehicle, and then they had a real vehicle, real car, and they have hit the test on it. Now the most exciting part is you will see how it feels when you are in the vehicle. So that is a collision warning system. Since the driver didn't take any action, it was automatically, it has a brake. So this was it was carried out in this test tracks. Don't try it. And in one of the projects that I was involved, I was sitting in the car instead of this truck, and then it feels very weird. Like you just see a truck going in behind, and it's very risky. I would like to show one other video about how many of you are aware of the adaptive cruise control systems? They are available in some of the vehicles now. I can show a short video for that one. This is also one of the driver assistance system. Can you hear the voice?
The adaptive cruise control automatically adapts to the actual flow of traffic. This means it maintains a constant time distance to the vehicle in front. It's a system that lets the driver know if the distance becomes critical. The wheel brakes are activated if the distance becomes unsafe. The adaptive cruise control system has a radar fitted to the front of the truck and interacts with eye shift and brakes. The driver selects a specific cruising speed using a button on the turn indicator stalk. The chosen speed is then displayed by a green LED on the speedometer. Adaptive cruise control lets the driver focus on getting there.
Are there any questions regarding the two videos that I have shown?
Yeah.
Or is the concept clear?
The concept is clear, but I'm just wondering if you don't start to trust the technology too much and start paying attention and something else can go wrong.
Yeah. Yeah, that's a very different topic. It's like legalization of this technology also. Like if something goes wrong, whom to blame? I mean, should we blame the company who manufactured this, or should we blame the driver? Or I mean, this is a big topic, and that's why it's not in market yet. This it's still slowly going on. So, as you may have seen, the adaptive cruise control system looks fine, but then in one of the it relies on this radar system. But the problem was in one of the tests that we have done, we saw that we were behind a big truck. We were in a car and we were behind a big truck, and the radar was not reporting any object. So we were almost, when we started, we were about to collide with the vehicle, with the truck which was in front. So it was a bit scary when to test these systems. And also it has a limited view. As you can see, this is a radar and it has a limited view here. It can't detect the vehicles here and here. So these are some of the problems in the current existing system. But we have some other sensors that we can use. For example, if you don't have something, what would you do? Maybe you will go and buy something, or maybe if you have a good friend, then you will borrow it from them, right? So similarly, what we do is, if all vehicles are equipped with vehicle-to-vehicle information or communication, they can send that this is my position, this is my velocity. Every vehicle is equipped with this device, and then it sends out this position to all other vehicles. So it's like we are cooperating with each other to reduce the traffic congestion, or we are helping each other to build a better system. So this is what is the one of the projects that we can do in making these adaptive cruise control systems in place.
2 minutes.
So the aim is that we have a sensor, we can have many other signals, and then we can combine the signals in a very effective way and use this information to control. This is the aim of the sensor fusion system. Maybe it may seem to you like a new concept, but I would like to give you an example, which is our human brain. I am now talking to you, and you are able to hear through your ears, and then you are seeing my face through your eyes. But somehow you are able to correlate my voice to my face, right? I mean, you don't see it, but then you are doing it without your knowing. So human brain is like a good system. You have two different sensors, and then it is combining this information, and you don't know that you are doing this. It just happens like instantly. So this is a best example of a sensor fusion system. And then we want to just imitate this system by having radar information and also vehicle-to-vehicle information. This is a vehicle-to-vehicle information. This is like a router, and every car is equipped with this router, and it can send and receive information. And then the sensor fusion system, it combines this information, and then it gives this output to each vehicle. And this is an example about the signal. Like we get the signals two different. This is a velocity of a preceding vehicle, of the vehicle which was in front of us, and then two sensors were reporting two different measurements. And then we have to believe which sensor is sending right information and which sensor is sending wrong information. And we have to study the properties of the sensors to take into account how to process this system. So this is just an example. So I hope that you can answer these questions. Maybe just take a moment to discuss with your colleague. Two of you maybe pay for some time, for 1 minute or so, and then try to see if you have understood these things. Otherwise, you can just ask me some questions. Maybe you can just discuss.
Yes. Necessary.
Because most of the accidents are driving.
Because I think main thing here is that we all using is the answer to this question too is kind of feedback thing.
I think that one is the adaptive cruise control that when you're driving and you have
all the
a car
time to the environment.
and then you
Really
okay,
need
well,
to
this
develop the school.
velocity and that distance to the car. But the cooperative adaptive, does that include that it uses sensors from the other cars as well?
Yeah, maybe I
Okay.
went it very fast. So the cooperativeness is that you cooperate with other vehicles.
So the sensor fusion pretty much.
Yeah, sensor fusion is like anything to do with combining information from different sensors. It is a very broad topic.
Okay,
When they had lots
so
of cars working
I
together.
don't think you got to explain the adaptive cruise
When you have this
using
radar,
cooperation
some
from
point
different
is
sensors.
in the way from you and the car that you want to detect. So what you do is that if each of these cars sends their information or their use of
Oh,
their
okay, yes,
environment,
yes.
then you can sum up the information and decide what's going on.
Yeah, sensor fusion is a very wide topic. It is like a just that you combine sensors from two, you combine information from two different sensors or many
An
sensors.
interesting thing
So
about
example is
that
like
that
was
if
given
in
human
the
brain because
browser from
it is a
you
very
is
broad
a
topic.
water
And one
accident,
instance is
can
this
send this
cooperative
signal and
adaptive cruise control where you have information from your own vehicle and other vehicles, and then you have to combine this information.
No. But that's science fiction, right? But that's further down the road. No?
A lot of research are done in that area, but they're not applied to the cars.
Okay, do you have any questions? Just put this slide. Are you clear with this, or do you have any questions?
I think we could answer the questions. Want to end it here?
Yeah, I mean, then I just want that you understood this one. Oh, maybe you can explain the third part.
My colleague will take that.
We discussed about maybe the car-to-car communication wasn't that clear,
Okay.
and I said if a car doesn't have enough information about its environment, that car can use the information of the other cars to add to his knowledge about the environment and to decide whether to go or whether to stop.
Yeah, I mean, I didn't want to cover like what are the problems. The thing is like we can't use the system in India, for example, because there are vehicles like bicycles and there are other things, and then we can't equip the system with all of them because the cost of the system may be much more than the actual vehicle itself, and maybe they will not buy it. So this is a solution that is this is a research phase, and this is applicable to European situation, but then it is not replicable entirely to other countries. But then I just wanted to, the main emphasis is that I want to know, I want to motivate why is the need of sensor fusion system itself. And then that idea can be used in anywhere. And one example is that we have used it for such cooperative adaptive cruise control systems.
I think the cost aspect was interesting.
Yeah. Yeah.
And I would say the safety is an important usage of these systems.
Yeah.